start by comparing the diameter of Venus to that of Earth. Venus has a diameter of approximately 12,104 kilometers. To put this into perspective, Earth's diameter is slightly large at about 12,742 kilometers. Venus compares in size to other planets in our solar system. While Venus is often referred to as Earth's sister planet due to their similar sizes, it's interesting to note that Venus is slightly smaller than Earth. However, it's larger than Mercury, Mars, and the Moon. Venus is the hottest planet in our solar system. The surface temperature on Venus reached a scorching 462 degrees Celsius. Venus has a super thick atmosphere, much thicker than Earth. Imagine Earth's atmosphere as a thin blanket while Venus has a giant, puffy comforter. This thick Venusian atmosphere is made up mostly of carbon dioxide, a greenhouse gas that traps heat from the sun. Think of carbon dioxide like a heat trap for the planet. Unlike Earth, where the greenhouse effect helps regulate temperature, the vast amount of carbon dioxide on Venus traps too much heat, causing the temperature to continuously rise. A runaway greenhouse effect. It's like forgetting to turn off the oven after baking a pizza. Venus is often referred to as Earth's twin due to its similar size and mass, and a density of 5.24 grams per cubic centimeter, close to Earth's 5.51 grams per cubic centimeter. Unlike most planets in the solar system that rotate in a prograde direction, when viewed from above their north poles, Venus rotates in a retrograde direction. This means that if you could stand on Venus' surface and observe the sky, the sun would rise in the west and set in the east. This retrograde rotation is unique among the planets and remains a topic of scientific interest. One's complete rotation of Venus on its axis, which defines a Venusian day, takes about 243 Earth days. This is significantly longer than the time it takes for Venus to orbit the Sun, making a day on Venus longer than its year. While the exact reason for Venus' slow retrograde rotation is not fully understood, scientists believe that tidal interaction with the Sun and possibly the gravitational influence of Earth might have played a role. Tidal locking occurs when the gravitational forces between two celestial bodies cause one to always face the other with the same side. While Venus is not tidally locked with the Sun, the slow rotation of Venus has significant effect on its atmosphere and climate. For example, the atmosphere circulates much more slowly than the surface, leading to a phenomenon known as superrotation. Winds in the upper atmosphere of Venus can reach speeds of up to 360 kilometers per hour, moving much faster than the planet rotation speed. Venus is dotted with thousands of volcanoes, ranging from small shelled volcanoes to massive volcanic complexes. These features include shell volcanoes, lava domes, calderas, and volcanic plains, covering approximately 80% of the planet's surface. Venus exhibits various types of volcanoes similar to those found on Earth. Shelled volcanoes characterized by broad, gently sloping profile, are common on Venus and can reach heights of several kilometers. Lava domes formed by extrusion of viscous lava are also abundant. Additionally, Venus features large volcanic structures known as coronae, thought to result from upwelling mantle plumes. The volcanic activity on Venus is believed to be primarily of basaltic composition, similar to the volcanic rocks found on Earth. Eruption on Venus likely involve the infusion of lava flows, the release of volcanic gases, and occasionally explosive eruption that produce ash and pyroclastic deposits. Despite Venus' surface being largely devoid of obvious signs of tectonic activity like plate boundaries and mountain ranges, its volcanic features indicate that the planet has undergone significant geological activity in the past. Some regions of Venus exhibit relatively young volcanic flows, suggesting that volcanic activity may still be ongoing on the planet. Much of our understanding of Venus volcanic activity comes from data collected by the Magellan spacecraft, which used radar imaging to map the planet's surface in unprecedented detail during the 1990s. These observations revealed the extent and diversity of Venus' volcanic features. Over time, Venus underwent a process of planetary evolution that led to the release of large amounts of carbon dioxide from volcanic activity, as well as water vapor from its oceans. These gases are potent greenhouse gases, meaning they trap heat in its atmosphere, preventing it from escaping into space. As the concentration of greenhouse gases increased in Venus' atmosphere, temperature began to rise. This warming caused more water to evaporate from the surface, further increasing the amount of water vapor in the atmosphere. Water vapor is an even more effective greenhouse gas than carbon dioxide, amplifying the greenhouse effect and causing temperature to rise even more. As temperature continued to climb, Venus' surface water began to evaporate and break down into its constituent hydrogen and oxygen. Hydrogen, being a light element, was gradually lost to space, while oxygen combined with other elements in the atmosphere or surface material. The runaway greenhouse effect reached a critical point where the planet's surface temperature soared to extreme level, causing a catastrophic loss of its surface water and rendering the planet's surface completely inhospitable to life as we know it. Without liquid water to weather and erode its surface, Venus entered a state of geological quiescence, with its thick atmosphere perpetually trapping heat and maintaining its blistering temperature. Unique to Venus, coronae are large circular to oval shaped structures surrounded by concentric ridges. These features are believed to result from the upwelling of hot material from the planet's interior, creating uplifted regions and circular depression. While Venus' thick atmosphere prevents smaller meteorites from reaching its surface, Venus' lack of extensive cratering seen on other bodies like the Moon due to its volcanic resurfacing, but large impact structures are still present. Tesserae are highly deformed, complex terrain region on Venus characterized by intersecting ridges and valleys. These regions are thought to be some of the oldest on the planet and may represent remnants of ancient crustal blocks that have undergone extensive tectonic deformation. Venus features vast plains covered by extensive lava flows, giving them a relatively smooth appearance. These plains, often referred to as planetae, make up a significant proportion of the planet's surface and are thought to result from extensive volcanic activity. Venus has a magnetic field, but it is much weaker than Earth. The magnetic field of Venus is about 0.015 times as strong as Earth's magnetic field. This weakness makes it difficult to detect and study compared to Earth's robust magnetic field. Venus is the second planet from the Sun, and its orbit lies closer to the Sun than Earth's orbit. As a result, Venus can appear relatively close to Earth in the night sky when it reaches its maximum elongation from the Sun, either as the evening star after sunset or the morning star before sunrise.